Hello guys, welcome back to my channel. Today we are gonna discuss problem number 55, that is jump game. This is a medium level problem. So this is the first medium level problem of our series. Let's just go to the description once. You are given an integer array nums. You are initially positioned at the array's first index and each element in the array represent your maximum jump length at that position. Return true if you can reach the last index or false otherwise. Let's just go through one of the example and get a better idea what they're asking us to do in here. So you are initially positioned at the array's first index. So for example number one, if you see, initially we are placed at first like zeroth index, and each element in the array represent your maximum jump length at that position. So we are positioned at zeroth index, and here the value is 2. That means we can jump either 1 or 2. So we can like jump for a 1 step or 2 step. So return to if you can reach the last index. So our goal is to reach the last index. So if we just go through this, here explanation is given. Jump one step from index 0 to 1. So if we jump, we can take one step or two step because maximum is 2. So if we have taken two step, then three steps to index 3. So our maximum is three steps. We can take a jump of three steps, and if we did a jump of three steps, we have reached fourth, for like last index. So yeah, that's correct. That's okay, fine. Like we got an idea what actually we have to do. So currently we are at the zeroth index, and certain like maximum steps are given to us for that particular position, and we have to find out like which if we are able to like using those steps, can we visit the last index or not. Let's just go through example number 2. Input nums equal to 32104. Here they have given output as false. Why? Because from the first step, if we try maximum like three steps, it will go to will be jumping to third index, index 3, and from there is no more jumps we can take. And even if we try one step, will if we try one step, then again max we can do two step, again we are at 0. Minimum we can do one step, and in this position as well, we can only go one step, and it will eventually will reach third index, and from there we can't like it is impossible to reach the last index. Got it. We have covered both the scenario. Let's just go through constraint once. What's the time complexity they want us to like perform this? So one is nums dot length is less than equal to 1, and is less than like greater than equal to 1, and less than equal to 10 raised to power 4. So clearly we have to solve this in O of n, or O of n log n time complexity. What are the possible solution that we can think of? A brute force approach would be recursive tracking. So we in brute force we try every possible jump, but that's too slow with exponential time complexity. As we know that brute force has 2 raised to power n complexity. So this is a pretty big range for that. If we add under 30, like if this range was 30, then we could have tried brute force. The next one is dynamic programming. Dynamic programming can work, but it's still uh, n to n square. So our complexity is going to be n square with dynamic programming, which is not acceptable if we go through this constraint. The only approach left is greedy approach. So if we solve this by greedy approach, in greedy approach, what we are gonna do? We are gonna go for maximum jump. So like we are greedy at local level. So if we are at here at this position, uh, so what's the max we can go? 2. So we'll go 2. What's the max we can go? 1. We'll go 1. eventually we'll reach. This is not the best step, but eventually we can find that this is not like a best path. If you can see in here, if you like put some logic in it, if we had taken one step, then we could have directly reached the fourth, like the last index. Instead of like jumping three times, we could have just jumped two times. But here, a greedy approach doesn't always guarantee we are getting the most optimized solution, but it guarantees that okay, is there a solution or not? Based on local judgment, we are taking global decisions, like decisions at global level. Let's just design this code. So the first thing we are gonna go is how far we can go. Farthest is 0. So currently, we don't know how far we can go. Uh, at every step, we're gonna find how far we can go, and based on that, we can we can print if it's true or false. So we can reach the last index or not. The next step we can do is we'll run a loop. So we are given this array. So we'll run this loop in this array, and if the element of arrays if the index of array is greater than far farthest. So here what is happening? If our I is greater than the farthest variable, will return. If we reach an unreachable index, we're gonna return false. So here we can return false. Else what happen? In each step, we're gonna calculate the farthest that we can go. So we'll take max, we'll compare it with the current value, as well as max we can go is um, the current index. So let's say for the first scenario, index is 0. The current index plus the nums of I. So the current index is 0, and what's the value for 0th index? 2. So farthest we can go is 1. Like towards in terms of index, we can go to second index 2. So if our loop is like successful, then we can return true, right? And if I is greater than the farthest, then we'll return false. Let's just try run this. If let's see if we get the correct answer or not. Okay, we are getting an error. What is it? If okay, we have given here n twice. Avoid making such silly mistakes. Nums, again we have made one more silly mistake. Nums is a list. Okay, it's passing the given test cases and it's taking 0 milliseconds. Same for this scenario as well. Let's just try to submit this and see if we get if we are able to pass the hidden test cases as well. Okay, yeah, we are able to pass all 174 test cases, and it's taking 35 millisecond runtime. So I think uh, this was a easy problem. Like I don't think we should categorize this at medium. Yeah, but the approach is bit tough if you're not aware of the complexities of various algorithms. So my suggestion would be like at least get to know about the complexities of the known algorithm like DFS, BFS, dynamic programming, greedy. In that way, you will get a clue from this constraint area, like which algorithm you need to implement. Yeah, that's it for today, guys. See you tomorrow. Bye.